Assalamualaikum warahmatullahi wabarakatuh and greetings to our panel. I are Razali Hassan. My name is AIMAN bin ISHAK and my department, Control Mechanism of Brainiacs Corp, will present our slide regarding our department's works and detail. We were tasked to design a wheelbarrow, so our company, Brainiacs Corp, decided to design a wheelbarrow with extra innovations, which will help a lot of agriculture workers and ease their work. As you can see in this slide, this is our Katia model drawing of our wheelbarrow. As you can see, it is a lot more different than normal wheelbarrow. Okay, so before we start showing what our department works so far, I would like to show the panel the Control Mechanism Department Brainiacs Corp organizational chart. As you can see, me, Muhammad Aiman bin ISHAK, as the head of department, and we have two designers, which are Muhammad RAZIF bin RAHMAN and HAIKAL bin MOHAMMAD. Also, we have Aidil Amirul AZAD as our financial manager and Muhammad DANISH as our manufacturing manager. And I would like to show you what our job scope is in this department. As the head of department of control mechanism, I'll have to provide clear and detailed direction and instruction to our members so that they could perfectly done their task. I also have to make sure that our group members understood and complete their task perfectly. Also, guiding members and communicate clearly with them and with the CEO of our company. Also, one of my job scope. As designer, they'll have to provide drawing and drafting of product. Also suggest suitable design ideas and guide members on Katia drawing, such as help them if our member need help in drawing in Katia. The financial manager of our department need to provide a financial report and information of department. Also find the most suitable part with the best price and budget so that we could easily manage our budget in the company. Also give financial advice and decisions. As manufacturing manager, they have to calculate the best design based on factor of safety and choose more suitable manufacturing process. Also, in the manufacturing process, the manufacturing manager have to guide the member on how to perform the manufacture. Here is our Gantt chart. Basically, it is our Gantt chart for the whole company, but also we apply for all the three departments. So, in the control mechanism department, we use the same Gantt chart where, as you can see, we perfectly done their work on time. Next, I will show you our meaning of meeting. Here is our meeting where we discuss most our detail and how to find the most suitable innovation for our product. This is where we choose our part, price, and manufacturing process. In this slide, we also provide evidence of our department discussion on our work. This is through application WhatsApp. Our department also perform a discussion on live through Discord platform, where here we easily discuss more clearly than through WhatsApp because on live everybody is here and everybody is welcome to throw out their ideas on our product. So next, on customer needs, we sent out some questionnaire to several agriculture worker and agriculture students, where we where we perform the questionnaire through Google Form platform. Here is some of our question on Google Form, where we ask the basic question on how they use the wheelbarrow. And from this question, we use their feedback, then we come for conclusion for what is the most better innovation that we could use on our wheelbarrow product. Assalamualaikum.
Assalamualaikum, my name is Muhammad RAZIF bin RAHMAN. I will continue this presentation where I will talk about development of our product. For our customer information, some of the benefit by using our product is our product is a creative innovation, time saving, consume less energy, and the last one, our product can increase work efficiency. For the first one, which is creative innovation, where we install an electric jack that makes it easier to unload the bucket storage, and we also install weighing system where it shows the current load weight. The second one is that our product is time saving because it is powered by engine, which will make it move faster and easily to move around, and also electric jack as I mentioned before. The third one is consume less energy because by the help of the engine and electric jack, it will use less force to move around and unload, and also it will prevent body ache as well. The last one is increased work efficiency. Our wheelbarrow can carry more load due to bigger bucket size and more work could be done at once. We continue this slide with the problem statement, which is number 1 is that standard wheelbarrow has an unstable design. Number 2 is that users are not able to use as their preference. Number 3 is that a standard wheelbarrow can cause back injury. Number 4, that standard wheelbarrow is hard to move around. And the last one is that standard wheelbarrow is hard to unload. We move to the objective of our project, which is to reduce the using of external force. The second one is to ensure health and safety. The third one is to reduce time while unloading, and the last one is to have a high mobility product. For the goal of the project, as we can see here by referring at the Sustainable Development Goals chart, to be more specific, our product is based on number 3, which is good health and well-being. Next is number 7, which is affordable and clean energy. And the last one is number 9, which is industry, innovation and infrastructure. Next, we move to the concept development. By referring the bar chart here for the battery, we will use the second one, which is PNS 12V 7.2Ah rechargeable lead acid battery, because it has the highest total score among these 3 options. Then we move to the bar chart for the electric jack, and we will use the third one, which is durable electric car jack. This is because it has the highest score among those 3 options. Next is the circuit layout for the weighing system and the installation of the Arduino in the circuit. Where at the circuit shown here, this is the whole circuit that will be represented in our product. And the last one is the working principle of the electric jack, which is the first one is to turn on the switch for the electric jack to run the jack. The second one is to press and hold the up button to lift the bucket upward in order to unload the load. The third one is to press and hold the button to make the bucket back to its original position, and the last one is to turn off the switch button to power down the electric jack. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAIKAL MOHAMMAD. I'm from Mechanism department. I will present the drawing for our department. This is our design for the wheelbarrow this year. First, on the motorized jacks with 430mm of wide and 137mm of the height, and the weight is 4.5 kg. The battery design with 151mm of wide and the height is 95mm, and the weight for the battery is 2.5 kg. And this is our control box with 90mm of height. The weighing scale with 50mm of wide and 36mm of height. And for the weight platform, the length is 739mm and the width is 578mm. and the thickness for the platform is 5 mm, and the last one is sensor with 50 mm wide and 50 mm for the height, and the thickness for the sensor is 10 mm. Next, I will present the material used and joining method. For the most standard jacks, the material used is described as heavy-duty steel. The American Iron and Steel Institute developed a classification system for the different type of iron and steel. For the joining method, the four metal pieces are all connected at the corner with a bolt that allows the corner to swivel. The screw thread runs across these assembles and through the corners. To reduce the weight of the jack by changing the manufacturability, we have to remove the welding to avoid the distortion. Next is the drive system and the product performance. Under favorable condition, the jack can leave wheelbarrow when it comes in contact with upper plate, which is caused by rotation of power screw through the electric power taken from the battery 12 volt. The suitable connect with the jack will be plugged in port, thus connecting directly with the battery. When the direction of the movement will be given by joystick, the power will be taken and the motor start rotating. Motor will transfer its rotating speed to the opinion gear meshing with a bigger gear, which is connected to power screw, and it will rotate. Next, for the safety fixture, it is stable and easily controllable by a switch. And the second one, capable of lifting wheelbarrow of a 50 kg to 100 kg. And the last one, the battery case used to protect from the bad weather. And that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muhammad SAUPI, and I have been appointed as manufacturing manager for this department. In our engineering analysis, first of all, we want to address on how we use finite element analysis on the jack and the base of the system. So we use 500 Newton in all of our analysis, and all of the study are in static analysis. So in the slide we're going to use two analysis. The first one is von Mises stress, and the second one is a displacement of the product. For the first component of the jack, we use slider. We clamp or fix the slider at the bottom, and for the distribution force, we use at the top of the curved surface and both of the cylinder on the both side. From the diagram, we can see max stress happen are at 5.49 times 10 to the power of 7. So, and the parts will not fail, since the max stress of the steel is 8.9 times 10 to the power of 8. Most from the displacement diagram, you can see most of the displacement happen on the side of the cylinder. For combined product, most constraint we use contact connection property between all the touch parts. We clamp the product at the bottom, and the force acting on the part is same as we use as in the slider. But from the stress diagram, you can see the stress acting on the product is exceeding the steel yield strength. So we conclude that the product will fail. And for our simple calculation for the scissor jack, from the diagram, the force analysis, we assume that the scissor car jack is loaded vertically symmetrical. For our next slide, we can simplify the mechanism at the joint of the top section, which the diagram showed. And the next slide, the calculation showed is to determine forces at the joint of power screw and arms using equilibrium forces. To finalize and justify our design, for example, in our potential customer needs, the feature design should be able to assist customer in operating with the wheelbarrow. This is shown by our initial research in customer needs when investigating the design solution for the problem. The questionnaire showed that half of our respondents frequently use the wheelbarrow. Then, beside if we better design better assistive feature in our product that appeal to a wide edge of range, it is more likely to attract more variable of customer satisfaction. In our actual result, and this is a jet we will use able to lift maximum of 2 tons, and our product only required to lift 50 kilogram. So the FEA we conduct are only for experimental purpose or as a references. For this Arduino schematic diagram, you can see this is the actual diagram we're gonna use in our product. We use 4 sensor as a receive input module. The green one for convert the physical input into the data, and we use Arduino as a CPU for our compute and our process.
Hello, my name is Aidil Amirul, and now I am going to present to you about our financial costs. Okay, now let's moving on to the first detail, which is the direct cost. The total cost for direct material is around Rm 401 ringgit and 50 cent, consisting of a durable electric car jack and an Arduino Uno Ultra starter kit, a PCF voltage reader, and PNS 12 volt rechargeable sealed lead acid battery. And next, as for the indirect cost, the total cost for indirect material is Rm 15 ringgit and 20 cent, consisting of a 50 kg body load cell weighing sensor. In relation to that, next is the total material cost, which sum up to be around Rm 416 ringgit and 70 cent. The following slide presented total expenses for both direct and indirect labor. For direct labor, the total cost is Rm 40 ringgit. Meanwhile, the total cost for indirect labor is around Rm 70 ringgit. Following that is the total summarized cost for mechanism department, which is Rm 486 ringgit 70 cent. And last but not least is the balance sheet presents the total assets for the second half of the year 2021, which cost Rm 1530 ringgit, and total liabilities and equity, which cost 1530 ringgit. Thank you.